Monitoring and Reporting. In this module, we will look at Dashboard, ACC, and Monitor, Log Forwarding, Syslog, and Configuring SNMP. Dashboard, ACC, and Monitor. Dashboard. The Dashboard tab widgets show general device information such as software version, operational status of each interface, resource use, up to 10 of the most recent entries in the threat log, configuration, and system logs. All of the available widgets are displayed by default, but each administrator can remove and add individual widgets as needed. Click the refresh icon to update the dashboard or an individual widget. To change the automatic refresh interval, select an interval from the drop-down list, 1 minute, 2 minutes, 5 minutes, or manual. To add a widget to the dashboard, click the widget drop-down list in the title bar, select a category, and select the widget name. To delete a widget, click the small X in the title bar of the widget. The dashboard. The ACC is an interactive graphical summary of the applications, users, URLs, threats, and content traversing your network. The ACC uses the firewall logs to provide visibility into traffic patterns and information about threats that can be acted on. The new ACC layout includes a tabbed view of network activity, threat activity, and blocked activity. Each tab includes pertinent widgets for better visualization of traffic patterns on your network. The graphical representation allows you to interact with the data and to visualize the relationships between events on the network so that you can uncover anomalies or find ways to enhance your network security rules. For a personalized view of your network, you can also add a custom tab and include widgets that allow you to look deeper into the information that is most important to you. Global filters. The global filters allow you to set the filter across all tabs. The charts and graphs apply the selected filters before rendering the data. Time. The charts or graphs in each widget provide a real-time and historic view. You can choose a custom range or use the predefined time periods that range from the last 15 minutes up to the last 30 days or last 30 calendar days. Tabs. The ACC includes 3 predefined tabs that provide visibility into network traffic, threat activity, and blocked activity. Each tab includes a default set of widgets that best represent the events and trends associated with the tab. The widgets allow you to survey the tab, including filters such as bytes, in and out, sessions, content, and URL categories. Local filters. Apply local filters to a specific widget. A local filter allows you to interact with the graph and customize the display so that you can see the details and access the information you want to monitor on a specific widget. A local filter is persistent across reboots. Global filters. Apply global filters across all the tabs in the ACC. A global filter allows you to limit the display to the details you care about right now and to exclude the unrelated information from the current display. For example, to display all events relating to a specific user and application, you can apply the user's IP address or username and the application as a global filter and display only information pertaining to the user and the application through all the tabs and widgets on the ACC. Global filters are not persistent. Promote a local filter to a global filter. Allows you to take a local filter, which can be an attribute in a graph or table in a widget, and to apply the attribute globally. When you elevate a local filter to a global filter, the display is updated across all the tabs on the ACC. Define a global filter. Define a filter using the Global Filters pane on the ACC. Promote a local. Select Monitor, Session Browser to browse and filter sessions that are current on the firewall. The firewall provides various top 50 reports of the traffic statistics for the previous day or for a selected day in the previous week. To display the reports, click the report names on the left side of the page under the Monitor tab. By default, all reports are displayed for the previous calendar day. To display reports for any of the previous days, select a report generation date from the Select drop-down list at the bottom of the page. The reports are listed in sections. Information can be displayed in each report for the selected time period. Reports can be saved to the local system in either CSV or PDF format. The specific number of predefined reports generated is variable and changes independently of firmware. To base a report on a predefined template, click Load Template and choose the template. You then can edit the template and save it as a custom report. One possible column is SAS, which allows you to see information about the use of hosted applications such as NetSuite, Salesforce, Workday, SharePoint, and Lotus Notes. Check the Scheduled checkbox to run the report each day at 2 a.m. The report then is available for viewing in the Reports column on the side. Click Run Now for the report to show up immediately. The Query Builder allows you to define specific queries to further refine the selected attributes. The Query Builder enables customization of the report using the AND and OR connectors and match criteria consisting of an attribute, operator, and value. You can then include or exclude data that matches the query. Queries enable the generation of a more focused collation of information in a report. Database. Summary databases for traffic, threat, and application statistics. Condensed. Detailed logs provide much more information but can consume a lot of storage and processing resources. Attributes. Match criteria. Sort by, group by. Sort by option specifies the attribute that is used for aggregation. Group by option allows you to select an attribute and use it as an anchor for grouping data. A completed report can be downloaded in PDF form. Note that the user group activity reports are not saved locally on the firewall. Select Monitor, PDF Reports, User Activity Report. Click Add and then enter a name for the report. Click the report. For a user activity report, select User and enter the user name or IP address, IPv4 or IPv6, of the user who will be the subject of the report. For Group Activity Report, select Group and select the group name from which to retrieve user group information in the report. Select the time frame for the report from the drop-down list. Note, the number of logs that are analyzed in a user activity report is determined by the number of rows defined on the max rows in User Activity Report on the Logging and Reporting Settings section in Device, Setup, Management. Select Include Detailed Browsing to include detailed URL logs in the report. The detailed browsing information can include a large volume of logs, thousands of logs, for the selected user or user group and can make the report very large. To run the report on demand, click Run Now. To save the report, click OK. User and group activity reports cannot be saved on the firewall. PDF summary reports contain information compiled from existing reports based on data for the top 5 in each category, and trend charts that are not available in other reports. You must use the predefined Sanction tab with the blue-colored background. If you use any other tag to indicate that you sanctioned an application, the firewall will fail to recognize the tag and the report will be inaccurate. By default, the report includes detailed information about the top SAS and non-SAS application subcategories, which can make the report large by page count and file size. Clear the Include Detailed Application Category Information in Report checkbox if you want to reduce the file size and restrict the page count to 8 pages.
Hi, my name is Chris Morosco, Product Marketing Director at Palo Alto Networks. I'm here to talk about Aperture, a new SaaS security service that we have. So let's look at a typical user connecting from a corporate network. They're connecting to a SaaS service. In this case, we'll say this is a sanctioned SaaS service. Hi, my name is Chris Morosco, Product Marketing Director at Palo Alto Networks. I'm here to talk about Aperture, a new SaaS security service that we have. So let's look at a typical user connecting from a corporate network. They're connecting to a SaaS service. In this case, we'll say this is a sanctioned SaaS service, meaning it's allowed, and we'll use Box Corporate. It's a great example of a sanctioned SaaS service for corporations. And the users are using this to upload files. Now, the challenge here and the security issue that we have here is that once this file leaves the network and goes into the SaaS application, we have no more visibility into it. It can be reshared, the share could change. Someone can come in externally and connect to the same account and have access to it, or they can introduce malware as well. This will all be completely invisible to the IT team within the network because it's happening in the cloud, not inline. And so there's a number of real concerns with this that you have to address specifically for these sanctioned applications. And so let's look at a few of them. The biggest one is malicious outsiders. These are people that are trying to get into your network regardless of SaaS. And typically they're using malware. And so because of that, we have to be able to protect from those people coming in through SaaS itself. They could use malware within the SaaS application in a unique way that they couldn't otherwise. Because there's nothing protecting or looking in this application, the issue that you would have is that someone could introduce malware, and because these applications support the ability to automatically sync with services on the network, you could have malware be introduced and then automatically sync with all services in the network. So it's very dangerous, and it's unique. Another one is accidental exposure. And in this case, this is this user sharing data, well-intentioned, maybe with third party, maybe even publicly, but they didn't mean to. Right? They accidentally shared data in the wrong way. They're not possibly trained. They don't have the right tools to understand if they've actually shared this data incorrectly. And these services are designed to be shared. And so because of that, it's very likely that they could accidentally share data. And it's actually very common that most corporations have some level of exposure that happens because of these well-meaning users doing the wrong thing. It could be that they've shared appropriately, but with someone else who can also share, and then they go and share inappropriately. Or they could share with an external vendor, and then that vendor ends up not being someone that they work with, but the share stays. So you get a stale share. So this is very commonly one of the most common issues. And then the last one is malicious insiders. And this is very similar, but in this case what's happening is that they're intentionally sharing this data. Either they share the data publicly and then they go somewhere and use an account to actually steal that data, or they share it publicly because they want to hurt the company in some way for revenge. And so we need to be able to address these specific issues for sanctioned SaaS. And that's where we introduced Aperture. Aperture connects directly to the SaaS service. And when it does that, it looks for a number of things. First, it looks for the data in the service. Is there sensitive data that's being shared? The credit card numbers, personal information, things like that. And it looks at it in a very fine way. It also uniquely looks at documents. And it doesn't just look at the document with the contents, but it also looks at what type of document it is, because we can use machine learning to learn the document itself. Is this document a legal form or a tax form or something like that would have sensitive data, so by its very nature it's a sensitive document. And not just what we've pre-programmed with the machine learning capability, but we can also classify custom documents. So if this company has a specific document that they want to be able to support, they can actually upload their own document. Aperture will learn what that document is, and then you can apply a policy and have visibility into it. The other one is you can see what users are sharing and how they're sharing, and then what the share types are. We talked about, is it public, is it internal, things like that. So these are really the key things that you're able to see from a visibility perspective, and you can have a much more detailed view of all these different components. Now, what about the malware piece that we talked about? And that's really the last piece that you want to be able to have visibility into. And so let's add threat here. Let's make it much more encompassing. And that's why we've introduced Wildfire. Wildfire is supported by Aperture. So when it does this check of documents and data within the application, it's able to use Wildfire to be able to determine if these are malware, if they're known, or if they're unknown malware. If it's a known malware, we can respond in a number of ways within the application itself to be able to quarantine that data. If it's an unknown malware, we'll work with WildFire to be able to determine if it's actually malware or if it's not. And in these SaaS applications, especially ones that are file sharing, it's very common to see a lot of malware being inserted in certain circumstances. In fact, we see quite a bit of malware for specific services that actually touch WildFire, sometimes as much as half the traffic that we see. And so because of that, you want to really be able to protect that with that WildFire integration and use Aperture to be able to remove that malware. So with all this data, you have good visibility. You can do deep analytics into what's actually happening within the services. But what do you do when you want to control these services, prevent these things from happening with the policy? Well, it's also very unique with Aperture because the way Aperture connects to the application itself, it connects direct. There's no way to evade this service, and the way that we get information is not inline. So if you set a policy today which says finance can share data with other finance people on Box, but they can't share externally, that policy typically applies today and into the future. It's with an inline service. But because we're not inline and we're looking at what's actually in the application itself, we can go back in time, into the past, and see what else was shared all the way since the beginning of that account creation. And in doing so, we don't have to rely on traffic that comes through and eventually we get to the point where we can identify something. We prevent it up front. Without waiting for an event to happen, we do full prevention because of that. So now you have a very strong solution in sanctioned SaaS to be able to have visibility and control within the cloud application itself. Now what about unsanctioned? Well, let's introduce the Next-Gen Firewall. Because the Next-Gen Firewall is excellent at identifying applications. It already identifies thousands of applications, and it identifies hundreds of SaaS applications today. And so we can use that to be able to control which applications are used, but not from a sledgehammer perspective where we just block all traffic, but we really want to be able to control that at a more granular level. So let's extend our Box solution here. Let's add Box Personal. And let's say, again, we have the finance team, and we want to have a policy which says, even though they can upload to Box Corporate, uploads to Box Personal are denied. Because we don't want to accidentally send data to Box Personal instead of Box Corporate. But the marketing team or other teams within the organization may require that you actually can download from external companies. And so because of that, we want to be able to allow downloads but not allow uploads. And this is a very common requirement for a lot of customers, say law firms, for example, who can't put data in a service like Box, but their clients do put data into Box. And so they need access to it, but they want to prevent uploads. And we can completely do that today. Now, what about services that you just don't want to support? Right? We have kind of the services that you know you want to support, you've sanctioned, and you have Aperture protecting. You have services that you want to have some control over, but they're unsanctioned. And then you have services which you just know you don't want to support because they may be dangerous. They may be redundant with other, say, file sharing services that you have. You don't want to have 5 of them. You can just define the one. So with that, we can define unsanctioned and block access to those unsanctioned services. And so that's all available today within the Next-Gen Firewall. But there's one more step that you want to be able to support, and that's really good visibility within the service itself, to be able to understand what the firewall is seeing, what users are connecting, how they're connecting, how much traffic's being passed. And we have that ability in the Next-Gen Firewall. Because we have the App ID capability and we have good reporting and visibility tools within the service itself, we're able to identify all those applications and generate reports and have visibility with analytics of the data behind it. And this is great for understanding what's happening in your network, just like we do with any other service, but it's even more additive with these SaaS applications because now you can use that to define even better policies and control this data even more based on what you see within this network. So that was Aperture. We're really excited about this new product. If you want to learn more, go to palotonetworks.com.
You can schedule the report for email delivery as a PDF file attachment on all models except for the PA200, PA500, and PA2000 series firewalls. For these models of firewalls, an embedded link is included within the email that will allow you to display the report in a web browser. The SaaS Application Usage PDF report is a two-part report that is based on the concept of sanctioned and unsanctioned applications. A sanctioned application is an application that you formally approve for use on your network. A SaaS application is an application that has the characteristics SaaS equals yes in the application details page in Objects, Applications. All other applications are considered as non-SaaS. To indicate that you have sanctioned a SaaS or non-SaaS application, you must tag it with a new predefined tag named Sanction, as in the example. The firewall and the Panorama Management Server consider any application without this predefined tag as unsanctioned for use on the network. Use the insights you have gleaned from this report to consolidate the list of business-critical and approved SaaS applications, and to enforce policies for controlling unsanctioned applications that pose an unnecessary risk for malware propagation and data leaks. Information shown for each application in the subcategory includes the top users who transferred data, the top blocked or alerted file types, and the top threats for each application. This section of the report also tallies the total number of wildfire submissions and benign and malicious verdicts for samples submitted by the firewall per application. Use the drop-down list for each report group and select one or more of the elements to design the PDF summary report. A maximum of 18 report elements may be included. To view the report, go to Monitor, Reports. Select PDF Summary Reports. Select a date. The report downloads as a PDF. Use the drop-down list for each. The Override Email Addresses field allows a report to be sent exclusively to the recipients specified. When recipients are added to the override recipient email or emails, the report is not sent to the recipients configured in the email server profile. Use this option for those occasions when the report is for the attention of someone other than the administrators or recipients defined in the email server profile. Log forwarding. To export the current log listing in CSV format, select the Export to CSV icon. By default, export of the log listing to CSV format generates a CSV report with up to 65,535 rows of logs. To change the limit of rows displayed in CSV reports, use the Max Rows in CSV Export field on the Log Export and Reporting subtab. Select Device, Setup, Management, Logging and Reporting Settings. After the first export, the system exports only logs collected since the last export. The log file will only include logs of the last calendar day. The firewall provides logs that record configuration changes, system events, security threats, and traffic flows. Logs can be forwarded to a Panorama Management Server. The Panorama Management Server then can generate SNMP traps or syslog messages and send email notifications. The firewall also can forward logs using HTTP, HTTPS. This capability allows the firewall to integrate with external systems that provide an HTTP-based API and to trigger automated actions when a specific event occurs on the firewall. Logs most commonly are sent to Panorama or to an external syslog server for long-term storage and analysis. Panorama provides the ability to manage a distributed network of Palo Alto Networks firewalls from a centralized location, where you can view all of your firewall traffic, manage all aspects of device configuration, push global policies, and generate reports about traffic patterns or security incidents. Panorama is available as either a dedicated management appliance known as the M100 or M500 or as a virtual machine. When the M100 appliance is used as a log collector, its maximum storage capacity is 8 terabytes. The M500 appliance supports 24 terabytes. Depending on the type and severity of the data in the log files, you may want to be alerted to critical events that require attention or have policies that require the archival of the data for longer than it can be stored on the firewall. In these cases, you want to forward the log data to an external service for archive, notification, and/or analysis. To forward log data to an external service, complete these tasks. Configure the firewall to access the remote services that will be receiving the logs. Configure each log type for forwarding. Define the server profiles for SNMP trap repositories, syslog servers, and email servers on Device, Server Profiles. Define the address of the Panorama Management Server on Device, Setup, Management. For System, Configuration, User ID, and HIP match logs, go to Device, Log Settings, and select or create additional server profiles. System messages about the firewall itself are visible in the system logs. Often, system issues arise because of changes made to the device configuration. Specific information about configuration events is logged in a separate configuration log for ease of troubleshooting. The system and configuration logs are good candidates for alerts over email or SNMP. Email and SNMP traps make the most sense for high and critical events that may require immediate attention or notification. And events captured by these logs include failed login attempts and configuration commits. Log forwarding objects are defined in Objects Log Forwarding. The log forwarding objects defines which server profiles to use and then uses this log forwarding object in security policy. These objects are defined separately for traffic, threat, wildfire, URL, data, GTP, tunnel, and authentication logs. You can filter the logs that are to be forwarded in two primary ways. By severity, where categories are predefined on a per log entry basis, and by query filter. The same logic is used as that used to filter log entries in the Monitor tab. Each security policy can specify a log forwarding profile that determines whether traffic log entries are logged remotely with the Panorama Management Server and or sent as SNMP traps, syslog messages, or email notifications. Different log forwarding profiles can be applied to different security policies. By default, only local logging is performed. Log forwarding profiles are consolidated on the Device Log Settings page. This page provides a single view of all the log forwarding profiles. These profiles are visible only to and can be applied only to the appropriate type of policy rule. Syslog. Syslog is a standard log transport mechanism that enables the aggregation of log data from different network devices, such as routers, firewalls, and printers from different vendors, into a central repository for archive, analysis, and reporting. To generate syslog messages for system, configuration, traffic, threat, or HIP match logs, specify one or more syslog servers with a server profile. After you define the syslog profiles, the profiles can then be used for system and configuration log entries. Syslog server. Enter the IP address of the syslog server. Transport. Select whether to transport the syslog messages over UDP, TCP, or SSL. Port. Enter the port number of the syslog server. The standard port for UDP is 514. The standard port for SSL is 6514. For TCP, the port number must be specified. Format. Specify the syslog format to use, BSD, default, or IETF. Facility. Choose a level from the drop-down list. Compared to traditional syslog over UDP, syslog over TCP SSL is a more secure method of transferring valuable syslog messages. Before PAN-OS 6.0, syslog messages were sent over UDP transport only. This method of transfer is not as reliable or secure as with TCP and SSL. Certain customer deployments have syslog messages relayed to centralized servers that may be sent over unreliable or unsecure links. Transport syslogs over TCP and SSL provide for more reliable and secure transport. TCP has more overhead and expense and overall performance than UDP, but the impact probably will not be detrimental to the overall performance of the network and environment. TCP has less overhead and cost than does SSL. If the syslog server uses client authentication, a local certificate is required. The private key must be available and cannot be stored on an HSM. Import a certificate into the Palo Alto Networks firewall. Purchase a certificate created by a Trusted Certificate Authority, CA. Generate a certificate signing a request to give the CA on the Palo Alto Networks firewall. Create a certificate by using Active Directory or some other facility with your own CA certificate. Create a self-signed certificate on the Palo Alto Networks firewall. Create a CA root certificate on the Palo Alto Networks firewall. Create a certificate signed by that CA root certificate. Configuring SNMP. If the SNMP manager is on a non-MGT interface, allow SNMP on the interface management profile for that interface. Also, create a service route for SNMP to use that interface. For the View option, enter an OID and a mask to determine which parts of the MIB can be seen. OID.1.3.6.1 mask 0xF0 to see everything. To see more information, use OID.1 mask 0x80. For the User's View, select View for User. Username, auth password, and private password should match in the SNMP Manager. Auth uses SHA. The SNMP community string should match the community string in the SNMP Manager. Enterprise-specific MIBs can be downloaded from https://www.paloaltoNetworks.com/documentation/misc/snmp-mibs.html. Note that for PAN-OS 7.0 and later, logical interfaces such as tunnels, aggregate groups, and vSys-specific subinterfaces can also be monitored using SNMP. Also in PAN-OS 7.0 and later, global counters have been added to the pan-MIB.mymib to track DOS-related events, IP fragmentation, TCP state, and packet drops. SNMP v2, trap repository address, community string. SNMP v3, username, engine ID. From SNMP, get OID 1.3.6.1.6.3.10.2.1.1.0. Passwords, auth uses SHA. Privilege uses AES.